This podcast is presented by the Commercial Space Project Group of the Space Generation Advisory Council. The SGAC, in support of the United Nations Programme on Space Applications, is a non-governmental organization and a professional network. Its goal is to convey the perspectives of students and young space professionals to the United Nations, space agencies, and academia. Hey everyone, and welcome to the Commercial Space Project Group podcast. I'm your host, Tsovinar, and joining us today is Carlos Abellán, the CEO and co-founder of Quside. His company is a pioneer in applying quantum technologies to secure digital systems, specializing in quantum random number generators and randomness processing units. Quside solutions provide the foundation for stronger cryptography and enhanced performance in security-critical computing applications, securing everything from enterprise networks to the next generation of connected devices. In this episode, we'll explore how quantum technologies work, their potential in the commercial space sector, and the journey of building a deep tech company from the ground up. So, without further ado, let's get started. Hello, Mr. Abellán. Thank you very much for joining us today. Let's begin with a quick introduction. Could you please tell us a bit about yourself?
Hi, Tsovinar. Many thanks for having me here. My name is Carlos Abellán. I'm originally from Barcelona, and I'm a telecom engineer by training. Then in 2012, I moved into academia and research, where I did a PhD in quantum and photonic technologies, mostly for applications around the field that was growing called quantum cryptography. And today I am the CEO and one of the co-founders of Quside. I guess we'll talk a lot more about that later. And we work at the intersection of digital trust, quantum technologies, and semiconductors for different markets. One of the most important ones for us at this stage is the space industry.
Sounds great. And could you also please tell us more about Quside? We'd love to hear about the company's origin and your vision for where it is heading.
Sure. Quside, we are a technology company based in Barcelona, mostly in Barcelona, although we have people around the world, and our focus is to develop advanced hardware for digital trust applications. We spun out from a research institute called ICFO, in the area of Barcelona back in 2017, after, as I mentioned, several years of research and development. Now, what is Quside focused on, right? So digital trust as a concept is about this idea that we use the internet for everything. We don't even realize, but we trust it. We trust that actually everything that we're doing is secure, about our privacy, about our authentication, to say who we are. So we're relying on that technology, and cryptography is a core technology to make that happen. Without cryptography, we would not have digital trust. Now, something that is very important to understand as well is that we cannot have this cryptography or secure implementations of cryptography without the ability to generate random numbers. And these random numbers for cryptographic use needs to be produced in some sort of hardware. Actually, we need to go into the physical world to extract unpredictability and randomness, right? So that's one of the challenges. We need to produce hardware-based random numbers to have strong cryptography, and we need strong cryptography to have digital trust, right? So that's a bit the intersection. Now, what are the challenges that we're finding these days? There are mainly two, right? One is, how do we know that the random numbers that we are using or that we are producing in our system are safe to use, are secure to use, and will protect our implementation? And that is a very hard and actually a profound problem. And the way we're doing it today is very limited, right? So what we're doing, we're exploiting quantum effects to get an extra layer, or let's say a fundamental layer of verification. We can verify that the random numbers that are produced are safe, right? This aligns into one of the main trends of security, that is zero trust and observability and continuous monitoring. The second challenge is that we have an increase in the number of keys, in the number of security and the data and the type of links and type of cryptography. So there's a need to produce more randomness. So we need more speed. Right, what we're doing today is typically not enough, so we need new solutions that go beyond. And that performance we achieve thanks to using photonics and semiconductor chips, right? So those are the two components. We generate random numbers in the company, quantum-based random numbers that provide verification layer and very high rate with the inherent scalability of building our own semiconductor chips.
Later in the podcast, we'll be diving into more and more technical terms. And, one of the most popular prompts for ChatGPT is to explain a difficult concept as if to a 5-year-old. Since much of our audience is made up of young professionals and students, some might not be very deeply familiar with terms like QRNG or other quantum technologies. Could you break down and explain some of these concepts in a simple and easy to grasp way for our listeners and honestly for me as well?
Sure. So maybe one of the first things is what is quantum, right? So quantum is a set of theory and some tools and some maths and physical insight that we have to describe what happens in the very small world, in the world of atoms, in the world of particles and photons and electrons. So it explains that, right? So we could not use the old laws of physics to explain what happened there. So people derived a new theory more than 100 years ago. So quantum is a theory of physics that allows us to explain the world of the small. People think, and there is this broad understanding, there is a very hard and complicated things, which it may or may not be, but what it is very counterintuitive, right? So there are things that happened in that tiny world that do not happen in our macroscopic world, and that's what really makes it hard, right? Because we don't derive an intuition. And then out from this understanding of quantum theory and quantum physics, people are building, including ourselves, quantum technologies. And that typically happens on three main domains. One is quantum computing, right? So we have people are building devices to compute, to use the laws of physics to build a new paradigm in computation. And probably the audience have read and listened to many things about the promise of quantum computing. Very exciting technology, field of research and field of industrial development. Then there is quantum sensing, right? So how can we exploit these laws of physics, these new technologies, to be able to see, to be able to monitor with more precision than we can do before, with many applications in many domains, including medical or others. And then there is the field of quantum communications. And quantum communications, by definition, is about how we send quantum particles from one place to the other. And that's one of the use cases. How do we connect quantum computers? But one of the most short-term applications is a field called quantum key distribution. And quantum key distribution is about sending quantum states between two devices and end up with cryptographic keys, shared cryptographic keys in both ends. So QKD is a specific case of quantum communication for application exclusively in cryptography. And those are some of the main terms. Then what we do at Quside is a technology called QRNGs, or quantum random number generators. Basically what we do is we exploit a very fundamental principle of quantum theory, which is there is unpredictability when you measure a quantum system. That story that you only know it when you measure, before you measure, actually it's undefined. So we exploit those sort of effects to produce numbers that are purely unpredictable, also with a main application in cryptography. So those are a few definitions: quantum theory, then technologies, computing, sensing, and communication. And then within communication, there is a specific application on cryptography for QKD and QRNG. Not sure I did it better than ChatGPT, but
Yeah, definitely. Definitely. So you mentioned that quantum technologies have many exciting applications, including in space, which we will get to a bit later. But for now, let's focus on communications. Quside's blog notes that satellite-based QKD helps overcome the distance limitations of fiber links, and that QRNGs provide the truly unpredictable randomness at the core of QKD security. How do you envision Quside's QRNG and QKD technologies being developed and integrated into the future satellite networks? And what do you see as the main technical or operational challenges in enabling quantum secure communication in space?
sure. Maybe it's worth explaining in a second a bit more about QKD, right? So QKD, at the end, you normally need what's called a QKD transceiver. Think just a system that transmits these quantum states. And then you need a QKD receiver, which is a device that will receive these quantum states. Now, when we talk about quantum states, we just need to probably to derive an intuition of the challenges. It means we send either a single photon from one device to the other, or just a few photons, right? So it's very, very faint amount of light and signal, right? So that already a big one of the challenges. One of the ways to build QKD or to roll out QKD is to put a fiber between the transceiver and the receiver, right? So the photon through the fiber will be guided from one place to the other. Again, we need to send from the transceiver to the receiver, so we need to guide the light. And light is not like an RF signal. It's very directional. You need to really send it from one place to the other. So fibers is a very specific example. Now it has some challenges, right? But fibers have losses, have bends, right? So this light is lost. And if we think about optical fibers for traditional optical communications, people use repeaters, right? So you will put repeaters in between, and then you will re-amplify the signal so you can go as far as you want. You cannot do that in quantum, because if you put a repeater, then that will force you at least to measure it and re-emit, and then you're destroying the quantum state, right? So it's really a single jump from one place to the other, and that has distance limitations. Commercial products today, tens of kilometers or even hundreds of kilometers, that is what you can do through fiber optics. Now, if you want to do an exchange of quantum keys through QKD between Barcelona and Berlin, then that's not something you can do with optical fibers, at least not with the current state of technology. So that's where satellites actually come into play. Because through free space optical communication, the distance that you can cover is much longer, because the losses as light travels through the atmosphere and from the satellite down to an optical ground station is much lower. So we can get to much longer distances, right? Now, that's about QKD and why space is a very important domain, where the European Commission and also several Asian countries are investing very significant amounts in having their own infrastructure and capacity. So there are many missions. We at Quside were part of several LEO missions and also a GEO mission at this point in time. Where do QRNGs come in? As I said, in this transceiver and these receiver boxes for QKD, you need to generate lots and lots of random numbers. Actually, one of the challenges is you need to generate lots of random numbers to get to a decent amount of what's called key exchange rate. Now, if we go back to the losses, think you have a satellite, in orbit, and it will be shining light from the satellite to an optical ground station. That's a big challenge. This is not an RF signal. You really need to be very precise on the pointing from the satellite down to an optical ground station, direct visibility. That means a lot of light is lost. So if you send a photon from space, not all of them will make it to the ground. Actually, many will be lost. So if you want to increase the amount of signal that is repeated, you need to send lots and lots and lots of states from space to ground. And to send lots and lots of quantum states from space to ground, you need to generate lots of random numbers. So those are two of the typical challenges that affect us. One is the losses, these forces for a very high operational rate, so clock rate. And this clock rate requires lots of random numbers that are flying on satellites. So you need to qualify the chips and everything that is required for satellite mission, but with the challenges of being optics, of being new components, of being very high frequency NRF, which is not that available at this point in time. So there are lots of efforts on that qualification journey right now.
Yeah, so there's still a lot of things to be done in this domain, but it sounds truly very exciting. Now, moving beyond just communications, we'd love to hear your take on other ways quantum technologies could impact the space sector, particularly the commercial space sector. Are there any surprising or emerging applications you find or you can think of that are particularly exciting? And could you share some examples or stories that illustrate their potential?
Mm-hmm. This is not an area that we as a company are active on, but of course there are different developments. Several space agencies are launching also challenges on how we can use quantum computers to solve some of the complex computational problems that we find in space, from signal processing on the one area. One that I've heard repeated times, and there are several papers and white papers, is on the mission planning, right? On the steps that need to be executed and how to optimize resources. That's a very challenging and computational problem that needs to be solved in some cases many times, depending on changing circumstances. And that's an area that people are very excited about, how quantum computers can help optimize that mission. The other is on quantum communications. We've talked about QKD. Some people are looking about exchanging simply quantum states to connect quantum computers, to do entanglement distribution that would allow maybe for better clock synchronization and timing synchronization. That's another area that sounds exciting. A lot of people are working on it. Then there is one that I'm not sure I would qualify it as a space development, but that will potentially affect significantly space development, which is around positioning, right? So of course we're now using satellites for positioning applications, right? Like Google Maps or whatever you want to use. It's a fundamental thing of our society, but the challenge, as we see, is that it can be disrupted, right? So you may lose access to those satellites. You may not be able to know where you are. And that in certain domains is very challenging. Some people are exploiting quantum effects to be able to get a very decent level of precision on positioning yourself without access to any satellites. How will that impact satellite-based positioning systems versus local positioning systems? That's something to be seen. I think that's a very, very exciting field to track and follow.
Great. And as quantum computing continues to advance, classical encryption faces increasing risks, and many countries, as you mentioned, are taking steps to prepare for that. From your perspective, what does the timeline for these quantum threats to current cryptography look like? How urgent is it for industries, including space and telecom and others, to adopt quantum-safe solutions and even think about it starting from today? And how is Quside helping its customers to prepare for a post-quantum security future?
Sure. You're framing it very, very clearly on this perspective of the quantum threat, right? So what really matters is that there is a threat to the way we are protecting data and that we need to do something else. That's something that since 2016 is very clear because the NSA at that point said, look, quantum computers are coming. This will disrupt everything. We need to start a new standardization process for the next generation of security standards, right? So there was a contest running, and it's still running, but from 2016, the first set of standards was approved or published in 2024, and it's coming into force now. All governments are publishing transition roadmaps to quantum safe security, right? Now, quantum safe security solutions, there's not only one, there are a bunch, right? QKD that we've talked before is one of those. And it uses the laws of physics to do this key exchange mechanism. And it's unique for certain applications. But there are others that you need a different set of tools, and one that is called post-quantum cryptography. And the name is a bit misleading. It doesn't use quantum technologies inherently. It's a different sort of computational algorithms that cannot be broken by quantum computers as far as we know, okay? That means they may be broken in the future if someone figures it out. There is no proof they are safe to anything, to any future developments of quantum computer. But as of now, this is what people are rolling out, right? So what's very important to understand at this point, and I'm saying that with perspective of being in this field since 2012, when people were not talking about any sort of application for quantum computer at scale, right? It is no longer about when quantum computers will be available. It is about being ready, comply with the timelines and the roadmaps that have been published, because the threat is no longer something you need to second guess. It's there. Governments have said you need to address it and you need to start rolling it out, right? And there is a very precise timeline from 2025 to 2035. So the next 10 years are going to be extraordinary in how people are adopting QRNGs and PQC and QKD in different applications. And the rollout is starting now. One of the arguments that a lot of people are using also to try to visualize that even if quantum computers are not available today, they are already a threat. Something that can be done and is being done, you can harvest data, you can just store it in a memory, and that's very cheap to do. And then in 10 years, when you have a quantum computer, you can go to that data and decrypt it and break it. And then maybe for whatever chat application or you don't care, but for applications in which your privacy really matters, or your banking information or your health records, that's already a challenge. So those organizations really need a solution today. That's one of the arguments that people use. The second that is extremely important is that migrating infrastructure, migrating security from what we have to something new is going to take a significant amount of time, money, and effort. And it's not going to be, okay, we want to do it and in 1 week it's done. it will be years, right? And then if you're thinking that the threat will be there in 5 and 10 and 15 years, and it will take you 5, 10, 15 years to migrate, you'd better start now, because otherwise you will definitely be very late to the party. One of the things we're definitely doing, and we've been doing for a very long time, is really building awareness about what's happening and what the solution landscape is and what you should be doing. So we work with customers on that basis, right? To help them understand what are the first steps you need to take, what to do, what are the risks, how it affects you. We always recommend you would need a small team or a tiger team inside that handles that in the organization. And some of the best organizations in the world are already doing that, right? There are groups and teams that are focused on the quantum threat and how to roll it out. That's on the awareness side. We're also building solutions. We're building the quantum random number generators. We're building cryptographic modules that people can roll out and really use them with quantum safe solutions today. That's the other thing that we are doing, right? And then on that combination, building awareness and helping you understand what to do and offering you solutions that may be applicable for your organization, it's the two main things that we are 100% focused at Quside right now.
It seems like when it comes to building a venture in a deep tech field, creating awareness is perhaps one of the biggest challenges. And I want to ask, beyond the technology itself, what would you say is the biggest challenge you face in the market today? Is it educating customers, competing with other solutions, or something else entirely?
So in my experience, since we started the company, right, and that's about a few good years, right, about 7-8 years as a company, and then another 5-6 years as a researcher. One of the things I'm learning about security industry is that it's, in a sense, is very conservative, right? It's conservative in the sense, in different senses. One, if it's working, don't touch it type of thing, right? It's secure, don't touch it. The other thing is that the certification and the compliance process is very strict, right? So it's a very complex field, very, very complex. So there are standards, there are regulations and certification processes that take a long time and a lot of money to crack. So when something is in production, really you don't want to touch it, right? And unless you have a very strong reason to change something, you won't do it, right? So that resistance and that resistance to change for new solutions has been a very complex thing to navigate years ago, right? But that is changing. As I said, this 2024, 2025 feels kind of an inflection point because of the new regulations and standards. People need to change their solutions. They now have, and they will change their solutions. So it's an opportunity to bring in innovation, to bring in new solutions, to make products stronger and safer on what some of my most trusted people in the industry call modernizing your cryptography posture, right? And of course, being it quantum safe is one. Being something that is called cryptogile is another one. That means that you don't want to have your security hard-coded, that you cannot change it 3 years down the road. If there's something happening and you need to change something, you need to be able to roll it out quickly. So this agility concept is very, very important. And the third element of this modernization also includes something that is called hybrid cryptography. That means that you will not use a single type of algorithm to protect your data. You will at least use a couple of them, so you default to the most secure, right? If one is proven insecure, you're still relying on the other. So modernizing your security infrastructure, your digital foundation infrastructure, is something we're passionate about. It starts with our quantum random number generation, with high speed, with verifiability. All of that really makes you more cryptogile, better supporting the hybrid, and better supporting the quantum safe journey. But then we're also expanding and giving you more capabilities as we're rolling out with customers. So I guess that's one of the main challenges in cryptography. Change has not been easy in the past, but it is easier now. But we still need to see the next few years as we roll out.
Sounds great. And lastly, returning to your personal experience, what has been the biggest challenge in moving from research to entrepreneurship? Are there any lessons or insights you would like to share with aspiring deep tech entrepreneurs?
Yeah, of course, there are thousands. So if there is an aspiring entrepreneur, so feel free to connect with me, and I'll be more than happy to talk and share views. But I'd say there are a few that are important and very generic, as I've been also talking to people, founders and also aspiring founders in this domain. First thing is that it's going to be tough. It's going to take a very long time. So you really need to love what you do and believe in what you do, that it makes sense, because otherwise it will be very easy to, leave it along the path, right? So really make sure you love what you're getting into and that it will take a long time. And it's not going to be a quick win in 3 months, right? So there may be some cases of that, but it's the minority. The majority takes many, many years and passion and perseverance, right? So make sure you understand where you're getting into, but the rewards are amazing and incredible, and the learning is something that I can't describe. You need to live it, right? Second challenge, typical of coming out from research into a company, is that it's actually the opposite path of the entrepreneurial path, right? Meaning that the entrepreneurial path is there is this big problem, let's find a solution to solve it, right? That's the concept and this customer discovery and all of these methodologies. Typically, when you're coming out from research into entrepreneurship, because you've been developing a technology at the state of the art, you're really doing something top notch, which is this thing, and then you need to go out and find the best market for this thing, right? So you need to find the best market. It's very horizontal, potentially many applications in many domains. You need to go and create the need, the demand, and this awareness. That's why in deep tech, the awareness is very exhausting, because you actually are trying to find the best problem, right? We're starting the opposite path. So make sure you understand that, because that means that from day zero, you need to have a unique selling hat. You need to go out and sell your thing. You cannot wait. You need to start day zero. And every day that you wait is the day that you lose. And I'm telling that by experience, right? So you need to go out and sell and find that problem that will justify the investment and will justify that your solution makes sense for the market. And the other thing that was also learning in our path, this was not very challenging for us, but I know several people that got stuck there, is that your job, even if you've been in academia and even if you've been a brilliant scientist, is no longer to publish papers or discover the next frontier of physics. Is to build a product or solution that someone will pay and that you will turn a profit, at least that you're not losing money as you're selling it, right? And that is your goal. That's your primary goal. And any focus on discovering the next frontier of physics, you're deviating attention and losing focus, and probably not in the right path. And if that's what you love, you can stay in academia, but probably not as a company trying to change from a deep tech company into a profit making organization. So those three learnings for me have or statements is what I would say. Someone that is in academia today or research and trying to move out, it's going to be tough. So make sure you love it. It's really about cracking the customer path and the solution, not about publishing papers and building great technology. It's also about building great technology, but for a purpose and for a customer.
So that wraps up our conversation. Once again, thank you so much for joining us today, Mr. Abellán, and for everyone listening. If you enjoyed this episode, please subscribe, share, and leave a review. Thank you for tuning in, and until next time, keep looking up and thinking beyond.
Many thanks for your time and for having me here. It's been a pleasure.